In today's video, we're breaking down 3 essential methods for medication dosage calculations: the formula method, ratio and proportion, and dimensional analysis. Understanding these methods is key to safe and accurate medication administration. We'll walk through how each method works and look at the advantages and disadvantages of each, so you can decide which one works best for you in different clinical situations. Let's get started. Medication dosage calculations are the mathematical methods used to determine the correct amount of medication that a patient should receive. These calculations ensure that patients receive a safe and effective dose. There are situations when you need to do a dosage calculation. First, when the ordered dose differs from what's available. For example, the medication order is Coumadin 2.5 milligrams. The medication delivered is a 5 milligram tablet. Also, for weight-based dosing. For example, for a medication ordered of heparin bolus 80 units per kilogram. Also, when using different units of measurement. The order reads digoxin 0.25 micrograms, but the dosage supplied is in milligrams. You need to convert and calculate. And when preparing IV medications, for example, calculating the rate of infusion. There are 3 different methods for performing medication dosage calculations. It's recommended to choose one method and stick with it when performing calculations in practice. The first method is the basic formula method. The formula method for dosage calculation is a straightforward approach to determining the correct amount of a drug to administer. You fill in the components of the formula and you solve. To determine the dose of the medication that you're to administer, you need to know 3 components for the formula. First, you need to know the desired dose. This would be the medication order, the dose prescribed. Then you would need to know what dose is available, what was sent up to be administered. Then you need to know the quantity. This is the form and amount in which the drug is supplied. 2 tablets, 5 milliliters. You take the desired amount, divide it by the amount on hand, and then multiply it by the quantity. This gives you the dose to administer. Here's an example. The order is for digoxin 0.25 milligrams IV push. The medication available is digoxin 0.5 milligrams in 2 milliliters. How many milliliters will you administer? Now you can fill in the formula. Start by placing the quantity of the medication supplied. In this case, that is 2 milliliters. Place 2 in the formula where the quantity goes. Identify the dose you have available, digoxin 0.5 milligrams. Place that number in the formula where it says have. The desired dose, the amount ordered, is 0.25 milligrams. Place that value in the top part of the formula. Now solve. 0.25 divided by 0.5 equals 0.5. Multiply by the quantity. 0.5 times 2 equals 1 milliliter. You would administer 1 milliliter of digoxin. Here are some advantages of the formula method. Number 1, it is straightforward and easy to memorize. There is one consistent formula that can be applied across many dosage problems. It's easy to learn and memorize. Number 2, it is fast for routine calculations. It's very efficient for problems like tablet or liquid doses when units already match. It's fast and efficient for simple problems. Number 3, it reduces the need to think in ratios. There's no need to set up proportions or cancel units manually. You just input values and solve. And number 4, it's good for multiple choice tests. It's quick and effective for exams where speed and accuracy are needed. Here are some disadvantages of the formula method. Number 1, it relies on units already matching. You must ensure that the units are compatible before using the formula. You can't use milligrams and grams without converting first. Number 2, there's no built-in unit tracking. Unlike dimensional analysis, it doesn't show how units cancel, which can lead to hidden errors. Number 3, it's not flexible for complex scenarios. It's difficult to use when calculations involve multiple steps. And number 4, it encourages rote learning over critical thinking. Users might focus on solving the equation without considering whether the answer makes clinical sense. The second method is the ratio and proportion method. This method utilizes equivalent ratios to determine the unknown dose. The ratio and proportion method works by comparing 1, the available medication, what you have, to 2, the desired dose, what is ordered. It is set up like this. A over B equals C over D. A is the dose on hand. B is the quantity that contains the dose on hand. C is the prescribed dose. And D is the unknown quantity, what you're solving for. By cross-multiplying and solving for the unknown, you can determine the correct amount of medication to administer. Here's an example. Again, the digoxin, 0.25 milligrams IV push. The dose available, digoxin, 0.5 milligrams for every 2 milliliters. How many milliliters will you administer? Set up your proportion. The first ratio is the medication supplied, digoxin, 0.5 milligrams over 2 milliliters. The second ratio is the desired dose, 0.25 milligrams over X mLs. When setting up the ratios, they must be arranged in the same order. Put the medication dosages on the top and the number of milliliters on the bottom. Now cross-multiply. You get 0.5x equals 0.5. Divide both sides by 0.5 to solve for x. And x equals 1 milliliter. You would administer 1 milliliter. There are advantages of the ratio proportion method. Number one, it's simple and familiar. It feels intuitive for many because it's similar to basic algebra or real-life comparisons. If one pill equals 10 milligrams, how many pills equals 50 milligrams? Number two, it's quick for basic calculations. It's especially efficient for simple dosage problems. Number three, it's visual and conceptual. The setup visually shows the relationship between known and unknown values, which helps some understand the proportion better. Number four, it works well with medication labels. Medications labels often give information in ratios, X milligrams per ml, which fits naturally into the proportion setup. And number five, it's a good transition from everyday math. It builds on math most people already use, recipes, sale price comparisons, making it less intimidating initially. There are disadvantages of the ratio proportion method. Number one, it is prone to misplacement of values. If you mix up the ratio, placing the dose ordered and the dose on hand in the wrong spots, you can get the wrong answer, even if the math is correct. Number two, there's a risk for unit confusion. You need to manually ensure all units match. It doesn't enforce unit cancellation like dimensional analysis does. Number three, it's less flexible for complex conversions. It's harder to apply when multiple steps or conversions are needed. Number four, there's no built-in error check. The method doesn't inherently catch unit mismatch or unreasonable answers. You have to check that separately. And number five, it's not ideal for visual thinkers who prefer canceling units. Some learners prefer to see how units cancel out and flow through the problem, which the proportion method doesn't do. The third method is dimensional analysis. It is a method used to calculate correct dosages by converting units, using conversion factors, and by making sure all the units cancel out properly, leaving you with the unit you want. Here is a structure for setting up an equation to solve for the amount of medication to administer using dimensional analysis. First, you identify what you need. This is a prescribed medication. It's what you're trying to figure out how to give. Then you multiply by conversion factors, which are known relationships between units or dosages, to help you convert to the correct amount. It could be the medication available or standard conversions. You solve for X, the amount of medication to administer. Here's our example again. The order, digoxin, 0.25 milligrams IV push. The dose available, digoxin, 0.5 milligrams in 2 milliliters. How many milliliters will you administer? First, you start with the dose that's ordered, 0.25 milligrams, and you place that in a fraction over 1. You set up the next fraction with the available medication. You must strategically place the units in the correct position so that the units cancel out and that you're left with the amount to give the patient, typically in tablets or milliliters or a similar unit. So the next fraction would be 2 milliliters over 0.5 milligrams. You put the milligrams on the bottom so that they cancel out with the milligrams from the first fraction, leaving you with milliliters. You calculate the answer by treating the problem as an algebraic equation and multiplying across. 0.25 times 2 divided by 0.5 equals 1. The milligrams canceled out. You would administer 1 milliliter. There are advantages of dimensional analysis. 1. It is a systematic and logical process. It provides a clear step-by-step path that minimizes guesswork. You always start with what's given and set up the equation so units cancel until the desired unit remains. Number 2, it reduces errors from wrong units. Dimensional analysis focuses on unit cancellation, helping ensure the final answer is in the correct units. Number 3, it's versatile and adaptable. You can apply it to complex multi-step conversions. Number 4, it's good for checking work. Since it's logical, it's easier to double-check calculations and catch mistakes. And number 5, it helps with conceptual understanding. It encourages thinking in terms of relationships between units, reinforcing your foundational knowledge. But there are disadvantages of dimensional analysis. Number 1, it can be intimidating for beginners. The structure can feel overly mathematical or rigid at first. If you're unfamiliar with fractions or conversions, the setup may be confusing. Number 2, it requires memorization of conversion factors. You still need to know your standard conversions. Number 3, it's time-consuming initially. Compared to the more intuitive or shortcut methods, it may take longer to set up, especially for more straightforward calculations. Number 4, mistakes can compound. If one unit or factor is incorrectly placed, it can cancel incorrectly and lead to a wrong answer, even if the math itself is correct. And number 5, there's less emphasis on clinical reasoning. Focusing on unit manipulation can sometimes distract from thinking critically about whether the final dose makes sense clinically. So how do you decide which method to use? It often comes down to preference, familiarity, and the complexity of the problem. Select the option that makes the most sense to you or best fits the clinical scenario. The dimensional analysis is often the recommended choice for dosage calculations. It works for all types of problems, features built-in unit checking, is logical and systematic, and error-resistant. The key takeaway. There are 3 choices in medication dosage calculations. Choose the method you're most comfortable with, and practice, 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 so it becomes second nature. You can find videos explaining each of the 3 methods, as well as practice videos for each technique to help you become proficient in dosage calculations at nursevideohub.com. Thanks for watching. If this video was helpful, give it a like, share it with your classmates or coworkers, and subscribe for more nursing education content. You can find more videos at nursevideohub.com. Watch, learn, and care.